First of all, consider a general acid. We consider HA. This is an acid. It ionizes to form hydrogen ion and this anion. So this is an acid. This is hydrogen ion which generates from the this acid, and this is the conjugate base of this acid. Why we call this as the conjugate base? Because now it has the affinity, or it has the tendency to accept back the hydrogen ion and to form a acid HA. Now consider an acid, acetic acid. This is the formula of acetic acid, CH3COOH. This is an acetic acid. It ionizes to form hydrogen ion and acetate ion. This is the acetate ion. So this is an acid, and this acetate ion now has a tendency to accept this hydrogen ion and to form this acetic acid back again. Now this acetate ion, we can also call this acetate ion as the conjugate base of acetic acid. Why? Because it has the tendency to accept the hydrogen ion and to form acetic acid again. Now we can conclude, or we can say that this acid, this form of acid, or this form of the acid is its protonated form. Why we call this as the protonated form? Because in this, the proton, this is the proton hydrogen, this is the proton hydrogen, the proton is attached to this species. In the same case, the proton is attached to the species. That's why the protonated, this is the protonated form of the acid. These both are the protonated form. This is also the protonated form of an acid. Why we call this as the protonated form of an acid? Because the proton is still attached to the species. Now this hydrogen ion and A negative is also an acid, because when these two combine, then it will again form the HA. This is an acid. In the same case, when the acetate ion combine with the hydrogen ion, it will again form a acetic acid, CH3COOH. So this whole part is also an acid, and this whole part is also an acid, like that of HA and CH3COOH. So we can call this as deprotonated form of an acid. Why we call this as this and this as the deprotonated form of an acid? Because in this, the proton is not attached to the acid. In this case, the proton is attached to an acid. The proton is attached to an acid, but in this case, the proton is not attached to an acid. This is the proton, and this is the species conjugate base which will combine to form an acid. This is the proton, and this is the acetate ion which is the conjugate base which will combine to form an acid. So that's why this whole is called the deprotonated form of an acid. Deprotonated form of acid. We could also call this as this whole as the deprotonated form of acid. This is the protonated form of acid. This is the deprotonated form of acid. Now tell me, is the protonated form of an acid or the deprotonated form of an acid, in which one of the following is charged or uncharged? Is the protonated form is charged, or the deprotonated form is the charged? And which of the following form, this protonated form of an acid, this protonated form, or deprotonated form of an acid, which one of the following is uncharged? So you can see that there is no charge present on it, but in this case the charge exists. In the same way, there is no charge present on this species, but in this case the charge exists, positive for the hydrogen and negative for the acetate ion. So we can conclude that the protonated form of an acid will always be this is the protonated form, this is the protonated form. No charge is present, so the protonated form of an acid will always be uncharged. So the protonated form of an acid will always be uncharged. So the protonated form of an acid will always be uncharged. So the protonated form of an acid will always be uncharged. So the protonated form of an acid will always be uncharged. So the protonated form of an acid will always be uncharged. So the protonated form of an acid will always be uncharged. So the protonated form of an acid will always be uncharged. This basic concept is necessary to understand how the acidic drugs and basic drugs absorb in the body, because they are related to the pH and pKa. We can also conclude from the above case that the deprotonated form of an acid are charged. So the deprotonated form of acid are charged. They bear a charge which may be positive or negative. The deprotonated form is charged.